On this episode of the podcast, I have with me Ben Birnbaum. He is the Senior Director of Engineering. He actually leads the machine learning team at Flatiron. We're going to cover a few different topics that tie back into healthcare, and we're going to be talking about some of the core problems that exist within unstructured data within his world and the challenges that the machine learning is trying to solve. And we're going to chat about how machine learning in healthcare is different than other domains. And I'm super excited to have him on the podcast. Ben, thanks for being on.
Thanks for having me.
Absolutely. So I know didn't do justice. I want everyone to have an idea of who I'm talking to. So set the stage for us. Give us a little insight in terms of who you are and what you're currently working on.
Sure. So as you mentioned, I provide technical leadership for the machine learning team at Flatiron Health. The majority of what we focus on the team is using machine learning and natural language processing to extract information out of unstructured electronic health record data coming from cancer so that it can be used for research.
Awesome. I guess just some context, like how big are, I guess the team that you're leading, you're the Senior Director of Engineering, how big a machine learning team you guys have?
Yeah, so we have about 20 people. There's 3 sub-teams. So one of the teams is, we call the machine learning platforms team, and they're focused on infrastructure and tooling. And then the other 2 teams are what we call capabilities teams, and they're more focused on building out machine learning applications. They work really closely with other product teams at Flatiron to kind of deeply understand their problems and build out novel approaches, and then hopefully build out some capabilities that can be reused and applied to new problems. So it's about 20 people. It's a combination of software engineers, data scientists, quantitative scientists who are typically coming from a biostatistics background, product managers, and some clinical data specialists.
Awesome. That's a nice size team. I mean, it's a big problem space. I'm sure that team's probably kept plenty busy. And I mentioned, I guess, at the top of the podcast, some of what you guys are doing in terms of the actual problem space you're tackling. Give us a little context in terms of what some of those are. I know we're talking about cancer, lab and clinical data, but I guess what are some problems that you guys are typically working on?
Yeah, I think it's probably best to start with kind of high-level context on what Flatiron does, and then I show how what we do on the machine learning team fits into that. So at the highest level, Flatiron is a technology company that's focused on oncology, and we own and operate the largest electronic health record system that's used by community oncology clinics in the United States. And then on top of the data that's coming in through this electronic health record, we normalize it, we harmonize it, we aggregate it, we de-identify it, and we make it available for research. And so while I think sort of conceptually simple, the key challenge there is that a lot of the most important information about a cancer patient's journey is locked in what we call unstructured data. So unstructured data in this case means things like clinic notes, radiology reports, lab reports. Often it's scans of faxes. So in healthcare, faxing is alive and well as a method of information transfer. And so we often see that information and we need to extract structured information out of it so that it can be used for research. So we have to do this at a pretty big scale. We have more than 2.5 million patients in our network, coming from more than 280 clinics. It's hundreds of millions of documents. And we need to do it at a really high bar for quality because of the kind of nature of how our data is being used. And so I think, when I first heard about this problem kind of coming from technology, the technology space, I just assumed that we use machine learning and natural language processing to do all of this. But actually, that's not what Flatiron does primarily. So what Flatiron does is that we use human expertise to process this information. So we have more than 1,500 nurses, oncology nurses, and what are called tumor registrars who use software that we've built to go into patient charts and pull out all of the structured information. On the machine learning team, we do the same thing. So when I came to Flatiron, we didn't have a machine learning team. The kind of human approach to doing this came first. But once we started doing that, we had all of this labeled data that we could use to start to automate pieces of this. So what we do on the machine learning team is we use the output of what these nurses, we call them abstractors, what these abstractors are creating, and we train algorithms that can start to reproduce pieces of this. So a typical input for us might be some unstructured electronic health record data, and an output might be some fact about that patient, whether that patient has metastatic disease, whether they have a specific type of cancer, whether they've received a certain drug, whether they have a specific biomarker, things like that.
So I know you came from Google, working in a different space. Obviously, Flatiron's working in a different industry, different vertical, solving cancer, healthcare issues. And I think for a lot of people, when they think about healthcare, they may not see the challenges, the modern, the sexy that exists, and obviously come from Google. You're working on different stuff, and I guess what were some of your preconceived notions? Like you weren't in the healthcare industry, you probably had some thoughts coming into it, and maybe the level of difficulty challenges that you might be anticipating. What did you see when you initially started at Flatiron?
Yeah, good question. I think a couple things stand out. So I think one, I underestimated the complexity of healthcare data and how to process it. If you look at a typical patient chart, it's often literally hundreds of documents. It's very messy. It can be, like I said, like faxes, contradict itself. And so I underestimated how easy it would be, I think, to process that in a way that makes sense and that's high quality. I think the other thing that was really interesting for me coming from Google is how cross-functional an organization I think needs to be to handle a domain like healthcare. So when I was on Google, everybody I talked to was a software engineer. At Flatiron, it's very different. I talk to oncologists on a regular basis. I talk to data scientists, clinical data experts, and we all have kind of our own way of approaching the problem, but we really need to communicate well with each other and work towards common solutions. And so the type of work that I did at Flatiron was much more focused on communication and understanding different viewpoints than I think it was at a more purely technical company like Google.
I could definitely see that. And it's funny is when you said faxes, and I know you guys, you'd mentioned lots of unstructured data. I'm thinking, there they are. And you're right, faxing still happens. I mean, I even went to doctor and one doctor said, I got to fax over your prescription. I was like, fax? And he was like, yeah, we fax it over. I'm like, okay, well, that's interesting. But when you start looking at that, like you're going, all right, well, we need to solve faxing data, right? Like there's a lot of data on faxing. Faxing's, you always don't get high quality documents. Is that part of when you mention unstructured data? Are you actually saying like you guys had to obviously find a way to get that fax data in as a part of the core problem? I know you mentioned a lot of natural language stuff that you guys had to tackle. Like, was that a part of the problem set?
Yeah, I mean, from our perspective on the machine learning team, we see kind of some data after it's been processed a little bit. So if you look kind of high level at what Flatiron does, Flatiron needs to build a lot of infrastructure to handle all sorts of different data types coming from different sources. For us, we see most of the patient's history as a set of PDF documents, and some of those have the natural language or just kind of the text available to them. But some of them, like those, for example, that would come from a fax machine, are scans of text. And so we need to first kind of OCR them in order to process them and run our algorithms on them. So we do need to deal with both types of data.
I guess, whoever's responsible for actually ingesting the fax data. I mean, OCR is amazing, but quality of faxes and different types of fax machines. I mean, I didn't think about it until now, but I mean, those little nuances could actually throw tons of issues in whatever, data prep you guys have to do anyways.
Totally.
That's kind of crazy. So I guess when you mentioned, I guess within the world of dealing with, faxes and labs and clinical reports. So outside of fax data, is there any other challenges in terms of building, the model that you guys need to kind of focus on within the cancer domain? Like what type of data goes into it? Like what are you guys actually looking at from the perspective of needing to have access to? I mean, fax data is probably just one component of that, I'm assuming.
If you just think of this as kind of natural language processing, there are a couple of problems that come up again and again that we have to deal with that are specific to the nature of our data. So I think one interesting aspect of the healthcare data that we have is just how much text is associated with each patient. So, maybe this is getting a little bit too in the weeds, but a lot of our problems kind of take the nature of text classification problems. And a lot of the kind of standard approaches that you might use don't necessarily perform super well off the bat because they don't perform well for large amounts of text. So we have some approaches where we search for relevant snippets of text based on some of our understanding of where that's likely to be so that we can kind of do some dimension reduction and deal with that data. I think another challenge is dealing with the different ways that you can pull information out of this and how it can even sometimes contradict itself. So we did some work a couple of years ago that's actually we published in a NeurOps workshop where we were trying to extract information about which drugs a patient received. And there had been some work done on this that looked at kind of toy data sets. And the work that had been done performed fairly well, but the data sets that they used didn't really resemble our data sets. So for us, if you want to find out whether a patient was on a certain drug, it's really longitudinal. Like you see one note from a specific point in time, and you might see patient is on drug X. And then you see another note from a week later, and the doctor writes, the patient was about to be on the drug, but insurance didn't approve it, and so we're going to go to drug Y. And then you might see nothing about that, what drugs the patients are on for 6 months, and then you'll see something where the doctor says, patient started drug Y on March 3rd. And so we have to really synthesize all of this sometimes somewhat contradictory information into a cohesive statement about when that patient was on the drug. And so we've had to kind of develop some novel algorithmic techniques to deal with that.
I mean, that sounds like quite a challenge to have to determine how one contradictory statement over the other might lead you down a different path. Yeah, and I was actually just thinking about, I mean, obviously, people are making decisions real time, notes get updated, they have to come back and different drug trials. When you're actually looking at this challenge within healthcare, is this, I guess, more relevant to, let's say, your type of data in terms of, cancer clinical, or do you think there's just the complexity in healthcare is just widespread because of how many different, angles and ways something could potentially go?
Yeah, I mean, I think there's lots of complexity all over healthcare, and it's not necessarily specific to oncology. I don't think I, necessarily know as much about all the detailed ways that it can be complex outside of cancer. I think some things that make cancer particularly complicated is that patients are treated usually for long periods of time, and there are multiple specialists involved. So there's the oncologist, there's radiologist, there might be a surgeon involved, and so there's just a bunch of different data that's generated for a specific patient undergoing cancer care. And I think that's one of the things that kind of uniquely makes it complicated.
And I guess when it comes to that standpoint, when you're considering like other domains, I mean, you did something else in Google, and from the aspect of machine learning in healthcare versus, let's say, other domains, what are like some of the core differences in terms of how it's applied, maybe some of the complexities that you're observing?
Yeah, great question. So I think one of the things that we've been really thoughtful about in doing machine learning in healthcare is just the domain itself requires a lot of respect and care. If you're using machine learning in industry and you get something wrong, maybe that, in the worst case causes a revenue reduction or something like that, which is obviously something you want to avoid. But it's different than if you're using machine learning in healthcare and, a mistake that your algorithm makes ultimately affects how care could be given to patients or what research conclusions people could draw. And so for us, we just think a lot about that. We spend a lot of time on the team, I think probably more than most machine learning teams, thinking about what happens when the algorithm makes a mistake. And so we do a lot of analysis for bias. We try to see if the use of the algorithm in producing these research data sets is creating bias, and if so, how we can mitigate it. We spend a lot of time thinking about monitoring for this over time. So just because the algorithm performs well when we build it doesn't mean that it will continue to perform well over time. And so we've, when we started the machine learning team, we spent a lot of time building out the infrastructure that we needed that would allow us to monitor the quality of algorithms over time. I think another way that machine learning, at least in my experience, has been different from machine learning in healthcare, and my experience has been different from machine learning elsewhere, is the level of transparency that's required. When we started using machine learning at Flatiron, it was a new thing for Flatiron. And, I've talked a few times about what the stakes are for the data sets that we're producing. And so we spent a lot of time just kind of internally talking about how we were using the machine learning, what the risks were, how we were mitigating them. And then we actually talked directly to our customers. And we were super transparent. We talked about how the algorithm worked. We talked about what the risks were, how we were mitigating the risks. And we did that before we launched our first model. And I think that was really necessary, especially back then, to get the kind of buy-in for what we were doing.
I guess just something you mentioned early on, and you guys obviously, you'd work with different products before having come into the healthcare industry. I guess, what's the relationship with machine learning? And I know you mentioned you had 3 teams there. and the product team. So I guess what kind of relationship, how close do you guys work together? Maybe you can talk to us a little bit about that.
Sure. Yeah. So there's maybe two ways to answer that question. So the first is how do we work with kind of the product management function at Flatiron? And then how do we work with teams that are more closely related to like the customer or products that we're building externally? So for the former, in terms of how do we work with the product management team, we're a machine learning team, but we have three product managers who work on the team. And so they really help us kind of communicate across Flatiron. They help us prioritize state problems, make trade-offs, stuff like that. And they're really critical for the success of the team and making sure that we kind of continue to provide business value to the rest of Flatiron. In terms of how we relate to other product teams, it's kind of an evolution, I'd say. So we're always kind of iterating on this. But so at Flatiron, we have kind of quarterly planning cycles, like I think a lot of companies do. And every time we do that, we spend a number of hours meeting with different teams, having what we call listening sessions. And we talk about kind of our partnership and how the partnership went in the quarter before, and just get a really like high level sense for what the product team is focused on, and then try to do a deep dive from there in terms of what areas may or may not require machine learning. I think one thing that's kind of come up again and again is sometimes it's not obvious what requires machine learning and what doesn't. So sometimes we might get a request for using machine learning, and it turns out that it's not actually that machine learning is required. It's more that just some like analysis is required that doesn't necessarily require model building. And then sometimes we'll talk to somebody and we'll hear, we'll hear a problem that they didn't recognize as possibly being suitable for machine learning, and we'll be able to see that there might be a machine learning approach there. So I think it's really important for us as a machine learning team to have lots of product context and to think really carefully about business needs so that we can kind of best provide value to the rest of the company.
I guess just a curious question, and I guess I've had other people answer this and curious of your thoughts. Do you feel like machine learning gets not overused, but do you think sometimes it's the hammer brought in to solve? Because you just mentioned that you obviously can push back and realize that you don't have to bring machine learning in. It's just maybe some other type of analytics. Do you feel that sometimes machine learning, especially the relationship with product, is just bring it in? That's what we need, and that's the initial thought, and then it's a little bit more of trying to determine whether or not that's the right fit.
Yeah, I think I love that you mentioned the hammer looking for a nail idea. We actually have a slide that we often present that has an image of a hammer looking for a nail, because we want to make sure that we're not doing that to the extent that we can. Especially in healthcare over the last 5 years, I think it's maybe maturing a bit, but I do think people are very eager to use machine learning, and I think sometimes people are interested in using it when it's not necessarily the simplest tool for the job. I think what we strive to do on the team and what helps us get some credibility is we'll often say, actually, machine learning doesn't make sense here. That's an important thing for a machine learning team to be able to do.
I've talked to a few people, and I think that's a challenge. And I actually have a podcast coming out. Somebody who spent time on the AI ML side and has gone into the product side, and she talks about that challenge of kind of assimilating to the product teams a little bit more while understanding the ML side. And I think your slide probably represents reality. But I guess it's when you're looking to solve a problem, sometimes you feel like the biggest and best solution is what I'm going to go to, just because that might just be the fastest dotted line to whatever I need accomplished.
Yeah, and it's we really on our team really do value simple approaches when they're possible. It's something we actually screen for when we hire. So when we're evaluating candidates, we'll ask them about prior machine learning experience and why they chose a particular approach. And it's definitely a big bonus for us if we hear something like, I consider this the state-of-the-art deep learning approach, but first I tried regular expressions because that seemed like the easiest way to get some initial signal, and that actually seemed to do the job quite well. That's obviously a hypothetical example, but we really do strive to make things simple when possible. And part of that's just because it helps us move more quickly, and part of that's because in general, simple approaches are easier to maintain and simpler to explain.
Absolutely. I guess, I was going to ask you because you got your PhD, and sometimes I like to ask, people who've gone down the path of getting a PhD. Did you actually pit stop into academia? Because just looking at the dates, I was like, it seems like you pretty much decided to go from maybe PhD to working at Google? Is there some bit of academia that came into play, or were you always kind of destined to kind of go work for industry?
So I actually had a very windy, uncertain path through my PhD. I started out my PhD really focused on academia. I actually, even before I worked on computer science, I wanted to be a theoretical physicist. And then I ended up moving from that to theoretical computer science at the start of grad school. So at the beginning of my PhD program, I wasn't even like using computers. I was spending most of my days at cafes with a notebook trying to solve problems and improve theorems and stuff like that. And about halfway through my PhD, I really realized that although that stuff was really fun and interesting and intellectually fulfilling, it was really important to me to work on something that had more practical impact. And so I actually took a break from my PhD and I spent about 6 months kind of just traveling around and not really sure what I wanted to do and really not even sure I wanted to go back and finish my PhD. Ultimately, I decided that I did want to go back. I focused on something really different in the second half of my PhD. I ended up doing some work in a really applied setting where I found some of my friends were in a lab where they were building applications for global health and economic development. And so I did some work related to that where I built some algorithms that could determine which data coming from that effort was high enough quality to use. And so that ended up being what my dissertation was about. And after that, I went immediately to Google because I really was more focused on the practical side of things. And I felt like going there was a great way to kind of beef up my software engineering skills and get some real applied experience.
Interesting. When I have somebody on from PhD program and they graduate, and it's always an interesting discussion because the thought of going in academia or the transition after academia always is an interesting view because it seems like they're just two different mindsets, two different settings for someone to kind of be prepared for the next step. Because obviously you're either doing research or you're getting ready to go apply. So yeah, I always find it interesting how the paths kind of change and intertwine until somebody gets out into industry and gets that first job.
I think for me, I really realized I'd made the right decision for me personally about 6 months into Google when I just felt like there were so many problems that needed to be solved. I think one of the challenges I think in academia is finding the right problem because you want to find a problem that is interesting from a research perspective, but is tractable. And I think that can actually be really challenging. And it's one of the biggest determinants of success, I think, in academia. But that felt very different when I was at Google, and there were just so many problems that needed urgent solutions, and I knew I'd never be able to solve them all. And I think, at least for me personally, that mode of working felt better.
Absolutely. No, well, I mean, a great outcome. Obviously, you're tackling solving some amazing problems. You might, I don't know if how much research components required now. A different type of research, I'd say, because obviously you're still creating new. So I'm sure there's a lot of thought that goes into it. But some fascinating stuff you're working on. I appreciate you being on and kind of sharing with us what you guys are tackling. I think hopefully everyone listening views it as something as a good for everyone because obviously you guys are working on a very important problem set over there.
Thanks, Amir. It's great to be here.
Absolutely. Thanks for being on. I just always like to ask if somebody wants to reach out to you, is LinkedIn, Twitter, do you have a favorite social platform that if somebody had questions or follow-ups that they could reach out to you?
Either LinkedIn or Twitter works great.
Awesome. Awesome. So we will include those links in our show notes. And that's it for this week. We'll be back again next week. Different guests, different set of topics. As always, if you have questions that you want answered or topics you like to see covered in a different podcast, always looking for ideas. Subscribe to the podcast. I'd appreciate that. That's how we get this thing out to more people. And until next week, we'll be back. Thanks.